This is lecture 14 of our Machine Learning 101 lecture series, and today we are going to be talking about Bayes Classifier. This lesson 14 follows from lesson 13, where we discuss Introduction to Classification in Machine Learning. Now, we mentioned that in classification we have a data set that made up of X and Y. This is like data set in regression. The only difference is that in case of classification, the Y values are discrete values. So they can either be 1 or 2. So let's say they can be just different classes. It may not even be numbers. It could be class 1, class 2, class 3, and so on. So it has to be discrete values. No decimal points. No. It's not continuous like in the case of regression. So you can review this by looking at the previous class. So now we have a situation where we have a type of classifier called Bayes classifier. This is different from k-nearest neighbor classifier that we are going to look at in the next class. So Bayes classifier works by using Bayes theory. So of course the name is very simple. Bayes classifier uses Bayes theory to operate. What is Bayes theory? Bayes theory is a theory in probability where you need to calculate the conditional probability of an event occurring. And that's why we call Bayes classifier as probabilistic classifier, because it calculates the probability and assigns the value of X to the class with the highest probability or the likeliest probability. So Bayes classifier is called probabilistic classifier, probabilistic. And now you can see why we mentioned that probability theory is one of the three fundamental theories of machine learning, because now in classification we are going to apply probability theory. Let's now see how it works. In the case of the cancer diagnosis example, here we take an example. The X-ray image of the patient is obtained, and we have this X-ray image X. Let's call it X. And we need to assign it into either C1 or C2. So in this case, we have the X-ray image, but we do not know the class. We have the X-ray image, but we don't know the class. Therefore, we need to calculate the conditional probability that let me just be writing it and explaining it. So we need to compute the conditional probability that this X belongs to class 1. We also calculate the conditional probability that it belongs to class 2. So if we calculate these two conditional probabilities, we check which one is higher and then assign X to the class with the higher probability. So that is basically how Bayes classifier works. So I'm going to write, just for emphasis sake, and also to remind you that you need to learn how to write Bayes theory easily without having to look at anything. I'm going to write it: conditional probability of CK of X belonging to class K is equal to the conditional probability of X given CK times the marginal probability of CK divided by the marginal probability of X. So what we are saying here is that this we already know, and this we already know, because this marginal probability of CK normally is known beforehand. Then we have marginal probability of X. Although it might not be perfectly easy in the real world example to get these values exactly as it is. But this is basically how Bayes theory works. So let's see. PCK. So this is a prior probability. So I've mentioned this in a previous class. Prior probability. So what this means is probability of C1 without having any test performed. So it means what is percentage of people with cancer who are patients, and what is percentage of people who don't have cancer with patients. So who don't have cancer and they are patients. So let's say we have 1,000 patients, and 1,000 patients in 1 year. Let's say in 1 year span, this hospital evaluated or diagnosed 1,000 patients, and they find out that 600 have cancer. So this is C1, and they find out that 400 don't have. This is C2. So it means that probability of C1 is equal to 600 over 1000, which is 6 over 10, and probability of C2 is equal to 4 over 10. So the hospital or the patient or the doctors already have this data. So this is actually the marginal probability C1 and C2. Okay, so now probability that CK given X is now the conditional probability of CK given the X-ray image. What is the probability that X belongs to either of these two? CK, of course, K should be 1 or 2. And this is called prior probability, right? So for the class CK, because the probability is known prior to taking the X-ray, right? So all these are prior. I'm going to write it. So this data is already available. You don't have to take an X-ray before you get to know this, because they already have it in the system based on over the months or over the years they performed diagnosis. They already have the prior probability before even taking an X-ray of the patient. So then the next time, CK given X. In this case now, we have is a posterior probability because we now have the value of X, meaning that probability of CK given the value of X. Now we don't actually know it, and we have to determine it. So it's called posterior probability because we are trying to calculate this probability after we've taken the X-ray image. So there is no longer the probability that we already know based on the number of patients we've evaluated in the past years. Is the probability now we want to calculate after we have taken an X-ray image of a new patient. So it's called posterior probability. Of course, you know that this is also conditional probability. So if the objective is to reduce the chance of assigning X to the wrong class, then we will choose the class that have the highest posterior probability, right? So calculate these two probabilities, P of C1 given the X-ray image, and we calculate P of C2 given the X-ray image, the same X-ray image, and we assign X, this X, to the class with the higher one. So X now will be assigned to the class that has higher posterior probability. So for any class that is greater than 0.5, remember the two must combine to be 0.5. For any class that is more than 0.5, that is a class that will be assigned the patient with this particular X-ray image that we have. So I'd like you to take some time to review this, try to read through, try to understand every bit of thing, everything I've explained, and try to see how you can also prepare for the next class. If this has been informative for you, like it and also share it. If there's something you need me to do or explain more clearly, leave it in the comment box below this video. I'd like to thank you for viewing, and before I go, I would like to mention that the next class will be another type of classifier called K nearest neighbor classifier. So we'll see you in the next class.